As a reminder, with all these example problems, I think it's most useful and most best for learning the material if you'll pause these at the start of the problem, try the problem yourself, and then press play to see my explanation. With each of these problems, it's very important that you show all of your work, show all the variables, the formula you're using, and all the work you have to get to the answer. This helps me when grading tests and quizzes to make sure that you know what you're doing and to give you credit for each of the things that you've done right. Okay, what is the acceleration necessary to stop a car traveling at 12 meters per second exactly when it reaches the stop sign that is 36 meters away? Okay, the given variables here, it's traveling at 12 meters per second. That's the initial velocity. The final velocity is going to be 0 because it's going to come to a stop. The displacement is 36 meters, and we're looking for the acceleration. So we list all the variables we know plus the one we want to solve for. Now look at this list of variables. We have VI, VF, delta x, and A. So we need an equation that contains those four variables. The equation we have that contains those four variables, VF squared equals VI squared plus 2A delta x. So 0 squared equals 12 squared plus 2a times 36. So if we do this out, 0 squared is 0, 12 squared, 144, 72a. Subtract 144 from both sides. So a is going to be negative 144 divided by 72. And we get an acceleration this time of negative 2 meters per second squared. The negative should make sense to us because this object is slowing down. Anytime an object is slowing down, the acceleration will be in the opposite direction of motion. Here's the second problem. A runner accelerates at 0.75 meters per second for the entire length of a 100-meter race. What is the runner's velocity as he crosses the finish line? So this time, we know the acceleration, 0.75 meters per second squared. We know the displacement, 100 meters. We know the initial velocity is 0, because he's going to start the race at rest. And we're looking for the final velocity. Once again, the four variables we're looking at, acceleration, displacement, initial, and final velocity. So once again, the best equation, VF equals VI squared plus 2A delta x. So VF squared equals 0 squared plus 2 times 0.75 times 100. So we multiply. So VF squared equals 150. So VF equals the square root of 150. We get a VF 12.25 meters per second. Now, a third problem. Passenger jet lands on a runway with a velocity of 71.5 meters per second. Once it touches down, it accelerates at a constant rate of negative 3.17 meters per second squared. Negative acceleration, positive velocity, so it's slowing down. How far does the plane travel down the runway before its velocity is decreased to 2? So we have an initial velocity, 71.5 meters per second, a final velocity of 2, an acceleration of negative 3.17, and we're looking for the displacement. So once again, same four variables, so we'll use the same equation. VF squared equals VI squared plus 2A delta x. So 2.00 squared equals 71.5 squared plus 2 times negative 3.17 times delta x. 2 squared, 4. 71.5 squared, 5,102. 112.25 negative 6.34 delta x. So I'll subtract 5,112 from both sides. I get 5,108.25 negative equals negative 6.34 delta x. Divide both sides by 6.34. It's negative. And I get a displacement 805 meters.